talk right now. I know. You go whenever you're ready. Let it down again. Where's the excuse? I didn't see one. Okay.
All right, so folks, thank you for having me here this evening. This is kind of a part one of two. My name's Doug Wilson. I am in some ways one of the OpenIOC people who talks about it a lot of places. This is a paraphrase of a talk I gave at first in Bangkok a couple months ago. And after this, my coworker Will is going to come up and give a reprise of a talk he did at the Black Hat Arsenal. These were, well, mine was at least originally a lot longer talk, so I tried to squish it down. If I'm going too fast, tell me to slow down. If I'm boring you, tell me to speed up or get the hell off stage.
Also been a NoVA hacker for a very long time.
What?
Also been a NoVA hacker for
Yes.
a very long time.
Yes. So, and I haven't contributed in a while, so here I am. All right, so anyhow, this is me. I'm a manager at Mandiant. I head the threat indicators team. We're part of the intelligence business unit. Been doing this for a while. My background before doing what I did now was sort of a combination of incident response stuff and multi-tiered web applications. I started out in the first .com boom as a web app and data center guy. So why are we here? Couple of questions. I'm skipping the first one because I don't think I have to convince a lot of the people here who work in security why it might be useful to share threat intelligence. These are some of the other topics I'm going to try and cover. So who here currently shares some sort of indicators or uses some sort of indicators in their job? Who does it in a format other than text files, Word documents, or CSV? Anyone? Anyone? All right, so first question, why a standard format? Well, so it's good that people share intelligence. Hopefully you are sharing intelligence with someone, you're getting indicators from somewhere, you're using this to power your incident response or your business. And this is all driven by people, and people like to share stuff, well, some more than others, but people tend to make mistakes. So a lot of the sharing models we've got right now, people are cutting and pasting, they're downloading Word documents, they're scraping stuff off websites. People make errors in translation, in transcription. If you email stuff to somebody, there can be delays while something sits in an inbox. You can send it to somebody's manager and they go, I don't know what the heck to do with this, and they pass it off to the wrong person. So the way to solve this to me is basically let computers do what they do best. Give them standardized data and let them process it. And what this does is also at the same time it lets humans do what they do best, which is basically focus on the really hard problems of figuring out how to get that intel and passing it into systems. I pretty much go with a mantra of automate the crap out of everything you can, and that empowers the humans to actually do the interesting work while the computers do the boring stuff. So what's this OpenIOC thing and why do you care? OpenIOC is a standardized format for sharing threat indicators. When you dig into it, it's XML. It's not rocket science there. To me, the important part, I'm biased because of where I work and the fact that we use it, but it's derived from years of what has worked for us, and we've done okay. It basically is a simple XML schema, and it's a list of what we call indicator terms, which are what you want to try and describe, like an IP address, a file name, a registry key, and then the ability that you can logically group them together. So instead of it just being yet another list of stuff being passed around without any context, we have the ability to do logical groupings and comparisons. So when you want to talk about a file, you can specify several things that have to be true at the same time to be able to narrow down what you're talking about. So I'll do a quick run through. This is really trivial compared to what you can do with IOCs, but proof of concept here. So you're examining this file. You found it on a box. You think it's bad. Bearing the name, there's some things you find out about. Like you run PE info, or you look at some of the aspects of the file. You run strings on it. And you're like, OK, hey, look, I found out this information. How do I depict this? So one of the things you do, the IOC basically starts out with a base level OR. It evaluates as a Boolean logic term, so you either have it as true or false. You can throw these things into an IOC. Now the problem here with the way this data is arranged is the fact that any file that happens to be that file size or any file that happens to have that file time is currently going to hit on this IOC. We don't want that. So we have the ability to combine stuff together and say that these things have to all be true at the same time. So if you start getting a bit more specific, the MD5 up at the top there, that's going to be pretty unique. Yes, there could be collisions and stuff, but let's ignore that for the sake of right now. In the real world, there's not going to be collisions for most files. That's pretty unique. That file string is not something you're going to see every day. However, you could easily see something with any of those other attributes. So we AND them together, so you have to have all of those at the same time. If you only had one or two out of those three, this would not evaluate as true. You have all of them, it does. So as some of you guys know, you may have people who run malware as an executable. It's often easy to run it as a DLL with a little bit of fiddling and repackaging. So let's say you're doing an investigation and you find out the bad guys recompiled that file as a DLL, and it's close to the exe, but it's not quite the same. How However, you want to make sure that you're recording the information about this particular set of malware together, because it seems to be the same attackers and the same stuff. There's many reasons you could do that, but let's just say it's your gut feeling on this investigation you want to record it together. Well, you can basically take the same IOC and add in more information. And again, this is a really simple example, but we have the MD5s at the top, because those are pretty much going to be unique. Has the same file string in both of them, that's going to be unique. So this can stand alone. Any of those hits, you're pretty darn sure it's the evil file. The other stuff, you want to have it grouped together. Now, one of the neat things about IOC, and it's also a good way you can shoot yourself in the foot, is that it's flexible. We can take the same data, and for better or for worse, we can represent it in a different manner. So if I start having a bunch of files that I want to group together, these are basically going to hit on the same files. Now, this also might hit on something a bit more, because you have file name contains evil instead of just the file name is specifically a particular thing. But do people understand why this, what would hit for the two files I've showed already, would also hit with this? Have I lost everyone? Is everybody just like cruising past?
It's like an SQL statement where you're doing a select like
yes.
instead of select equals.
Right, and you do have the ability to do different operators. So you can do contains and you can do some negations. But long story short, you have the ability to flexibly describe what you're looking for. And as you learn more information about binaries or TTPs during the course of an investigation, you can custom tailor your IOC and change it over time. So in a way, it's kind of like an investigative notebook that can be consumed by certain security products. So for the sake of time, I'm only scratching the surface. We have something like 500 terms that we respect right now. Realistically, we only use about 70 of them, but they cover a lot of different things. It's very Windows focused right now because most of our business is Windows focused, but we're looking to expand into OS X, Linux, and various other things. If you're interested in that, come see me. But you got a lot of flexibility on how you describe stuff. So one of the other things, though, is that basically right now, we've been doing this for a while, and a lot of other people are starting to get into this game. So I want to sort of give some advice to people like, oh, that's cool, I want to use this, or I want to use Cybox, or I want to use something else. If you've been to any of the big trade shows this year, Intel is the new APT. Like APT was a couple years ago, everybody's got Intel. It's on everybody's sign, it's driving everybody's security, everybody uses it. A lot of people are jumping on this bandwagon, and that's good. And I think everyone should start with using a standard. But I'm here to sort of give people a warning from the experience we've had over the past like 5-6 years, which is that just jumping onto, I'm going to use a standard, introduces a whole new set of traps on how you process Intel. So using a standard is a start. And I don't mean to knock CSV. It's kind of a crawl, walk, run scenario. Something like OpenIOC is a little bit of a pain in the ass to figure out, and then you have to have products that use it. You know, full disclosure, Mandiant's products use it, and a couple of free things do. It's not completely used throughout the commercial world. But more vendors are looking at adopting it over time. More people are trying to interact with it. But start with some sort of formalized method. Don't just have lists without any sort of context. But if you do start with a standard and you start saving stuff in OpenIOC or any other format, I'm going to ask you to please do these 3 things to keep your Intel from turning into a complete crapshoot. First off, make sure you maintain the context when you get Intel, because way too many people will push stuff around without any context, and basically Intel without context turns back into data. The other thing is, it's all great and wonderful to jump on the Intel bandwagon, but if you can't act on that Intel, you're wasting your resources. Get it to a point that you can act on it, and then dig into the Intel world. Don't try doing Intel first, because you have a nice pile of Intel and nothing you can do with it. And the last thing is this idea of curation. Intel has some intangibles that change over time. Intel may not be useful all the time. Intel may basically end up being in big piles. You have to go through a curation process where you're constantly checking up on your Intel and making sure it's still worthwhile. So context, what are you talking about? So this file here, I find this file in the course of an investigation. It's a Windows file. Yay, it's on a Windows box. Is this a system file? Well, if it's in one directory, that's where it's supposed to be if you have a fax server installed. If it's in another directory, that's not where the fax server is supposed to be at all. And that might possibly be something bad. So where it's at is going to be one piece of context, and you can start adding in other attributes. You could look at the other file pieces we've looked at, and you can go and check with Microsoft and see what the actual file is supposed to be. And if it's not signed by Microsoft with the right file attributes and it's in the wrong directory, might be a hint that it's something bad. This is a way you can sort of encode context in the indicator if you put this information in there, and you can pass this along. So instead of just saying, hey, look at fxsst.dll, which unfortunately a lot of intelligence reports may have, here's a bad file, you get more context to help you know when you find that file, because people may masquerade as good files as to whether it's good or bad or not. Another really simple context example, a lot of people do this in the DIB and other areas. They'll say, hey, these IPs were used in an investigation. Block them. So the problem is, some of these are things you don't necessarily want to block. And none of these is a real C2 server, but say 10.10.10.10 was. But this happens a ridiculous amount. You'll get a list of something simple, like MD5s or IP addresses, what we call an artifact, which to me is a set of data. And without any context, this is just data. You don't know why this matters, but people will do this all the time. They will ship lists of stuff around, or there'll be a bulletin and somebody will scrape indicators out of it, and they'll just make a list. I don't want to name any names, but there was a really awesome blog post from the chief technical officer of some division of a very large security company a couple weeks ago. And the security thing was like, blah, 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 update on some campaign. And somebody forwarded it to me, and I was like, oh, great, another bulletin with some artifacts in it, and maybe somebody can, and like, I skimmed down a few lines, and it's like, insert name of company now supports OpenIOC. And I was like, wow, that's awesome. That's so cool. Like, they never even told us they were supporting OpenIOC. That's really cool to have this big vendor like saying this is awesome. So, and they're like, here, download our indicator and click on this video to see how you can use OpenIOC with insert vendor's names to your product. So I'm like, okay, wow, this just made my day. My week is awesome now. Click on the YouTube video. So they go through, they show the console in their web monitoring software, blah, 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 and there's an import button, and there's a import file button. I'm getting very excited. And if you've seen an IOC file, it's basically a big chunk of XML. And so they're like, open up the file. They open up the file. Choose file delimiter. Wait a minute. This is XML. One file delimiter was the bracket one way. One file delimiter was the bracket the other way. Use these to remove the entire XML to basically get a list of stuff. Now delete everything that is not a domain name. You have just imported an IOC. That's the whole crawl, walk, run thing. So basically what they were doing is they were ingesting some of our IOCs that came with the APT1 report, and they were removing every piece of context. So one of the important pieces of context I mentioned is negation. So it could be not this domain name. They didn't care. It was outside the file delimiter for XML. So context is important. Anyhow, I kind of went over this stuff already. Basically, not only what to look for, but why you're looking for it. If you start storing stuff in a standard and you start moving information around, make sure the context goes with it. Whatever format you're doing, doesn't have to be OpenIOC, but make sure when you're communicating to other people in your enterprise or other partners or anyone you want to share with, if you don't have that context, the intel is basically useless. And again, as I mentioned, you need to be able to act on it. So we've covered, you want to standardize, you want to maintain context, but if you can't act on it, you are wasting your resources. And I see so many people buying Intel products and driving to get to Intel, and it's like, so what's your network monitoring look like? What do you mean? Well, can you see what's happening on your network? What do you mean? You know, the first place you should be able to do Intel work is on your own stuff. It really doesn't matter if you know that APT group 625 located somewhere outside of Shanghai is attacking you if you can't tell when they're attacking you. So another thing I encourage is a lot of these people are getting this push. You got to get in data. You got to do this stuff. Make sure you know what's happening on your network, and make sure that if you do have Intel, it's something in whatever format that just plugs into what you use, or through a few scripts and transforms can plug into what you use so you can actually use it. Because I'm seeing people investing money in this great Intel stuff that they can't use at all. I've even seen it with some government contractors using some government systems. I saw a demo of one the other day. Again, I'll leave it nameless, but it was a really neat way of storing a bunch of Intel and indicators. And then somebody on the call asked, so how do you export those out and put them in a system? The operator of the system couldn't tell us. So, and my final point here that we've learned that I think is important is curation. So once you get into this Intel world, it can be overwhelming because there's a ton of data out there. And unfortunately, another thing that's been happening at a lot of the presentations and conferences is all the big vendors are going, big data is big Intel. And that's not really true at all. There needs to be humans looking at it, making distinctions. And the other thing that we found that is the big gotcha is different groups use Intel differently. So you get intelligence, you start piling it up. So we basically had this problem. We got lots of IOCs. We've been using this internally since before I was at the company. I think it started like 6-7 years ago. Everybody's writing IOCs, everybody's shoving them in a big pile. And over time, our pile of threat indicators grew bigger and bigger, but more people would go dig out that pile and be like, this doesn't work for me. It's not necessarily that it's bad. But what happened is that the person who had written it was in a different business unit with a different use case for that intelligence, and they just kind of threw it in the pile. So what we found is that you really need to look at what users and business groups' needs are and make sure that you're supplying them with the right stuff. So I don't have anything snazzy like the kill chain, although some parts of this can map to it. But like, you sort of have a reference set of intelligence. This is stuff that's not particularly technology dependent. This is the list of bad stuff about the bad guys. But if you have people who are doing investigation work, who are doing detailed incident response or malware analysis or other things, they're over here in this corner. They're basically very dependent on their technology workflow, and they want to cast a broad net because they have the time to investigate and to dig and to learn and to turn up new stuff. Conversely, your standard SOC situation is on the other side. They're also going to be dependent on their technology, but they want low false positives, because if you have a bazillion false positives, your SOC or knock people's heads explode and they don't get stuff done and they scream and they cry and they hate you very much. So what we found is basically we were kind of piling stuff up from all these different things into a centralized pot, and that was not working very well. So we introduced this idea of curation, which is each business unit that is using intelligence, be they working on investigation or working on detection, needs to have their own life cycle where they tune what they're doing to work for them. But then they also need to check in with a centralized body who's coordinating stuff across all the company, because otherwise you have one of those left hand doesn't know what the right hand is doing. So my group has been stood up, and we're basically doing this for all of our intelligence, not just indicators. My group happens to do the indicator part, but we basically are that centralized role. We coordinate all the reference intelligence, we coordinate all the stuff that's coming in from external sources, and we make sure that we have a hold of it, but we also make sure that we're handing out the right parts that the other business units need. And so if you work for any size of organization where you've got some people doing detection and some people doing investigation, you're ultimately going to run into this problem. And I don't have a magic cure other than to say make sure someone pays attention to that diff, because if you let it grow for too long, it will tower up and crash down on your organization and it will suck. So what's next for us? Realistically, the thing that I've realized, especially since we've been dealing with so many of these over time, in the sort of crawl, walk, run, I want to get to being able to fly. If you store a lot of your threat intel in IOCs, you're really having this huge document management problem. It's like if you had a big website and you wrote a few of the pages in HTML, and you wrote a few more, and you wrote a few more. There's a reason people came up with the idea of data-driven web pages. We're kind of getting to the same thing with Intel. So I'm not saying don't start by recording stuff in a standard format and all the stuff I did. It's just once you move to that, the next generation I see is the fact that we have to start moving to just having pure data. And the indicator formats, be it OpenIOC or Cybox or anything else, are going to be how you communicate it. So the next challenge that we have ahead of us, having juggled through the stuff you've seen there, is that we have these massive silos of intel. They're getting smarter every day. Really what you want to do to be on the top of your game is query them regularly and then communicate using the standardized formats. It's great to write IOCs, it's great to store stuff in it, but eventually it becomes that big pile that's going to topple over on your head. So how do you get involved? I'll breeze through this real quick. We have a website. It's a little outdated. We're going to revise it soon. The important part, hopefully the people in this room, because you like to tinker, and what Will's going to get into is we've been doing this for a while. So we just came out with a new version of this, and we just stuck it out for public comment. And that's part of what Will's presentation is going to be about. But we have it up on GitHub if you want to look at it. Will's thing up next is also on GitHub. And we have a Google group and various ways to get a hold of us. So conclusion slide. I told you stuff. I won't dwell on it for time. You can talk to me later. That's me. Questions?
How long ago?
What?
How long ago?
How long ago what? The picture?
Yeah.
Dang, do I look that bad?
Your hair is grown a little bit.
That was well, no, it's put back in that picture. That was within this year. So.
Just wondering if you put a date, like a birthday field in the data that said when it was entered, and then in your selection criteria, you can say with something newer than this date. So you don't delete data because bad guys might reuse something that they used 4 years ago. So you still want it there, but you don't necessarily want the business unit to report on it.
Gotcha. So the way we're approaching that is we have the luxury of having enough resources. We have an entire different group that tracks threats and determines when they are or are no longer pertinent. And they basically tell us when we should get rid of old crappy data. If you were sort of doing it all in one, you could do that. One of the things that we've introduced in 1.1 is this idea of parameters, which is assignable metadata. So if you wanted to build your own thing that literally tracked when each piece was entered in, you could do that. We tend to do it through a version tracking system. Like we basically store our IOCs in a source code control system that lets us know when changes happened. But we actually have a different group that will occasionally say, yeah, we haven't seen that in 2 years. You can probably drop that one off.
Why would you drop it?
So here's the thing, technology is not perfect, and if you have 100 IOCs running in something that can process IOCs, it runs more efficiently than if you have 1,000, than if you have 10,000, than if you have so on. And ultimately, with a lot of the modern technologies out there, if you try cataloging everything you know, it will work, but it will not work in a speedy and timely manner to cover all 100,000 desktops of an enterprise on a regular query. So it's a data management problem. In a perfect world, we never want to get rid of it, but we have the luxury of being the people who have the data warehouse and are looking at it. The people who have to put this in some sort of endpoint protection system and then have it parse in real time across hundreds of thousands of desktops, they go, yeah, we can only handle X or Y number of these. So ideally, I agree with you. Technologically, there are a lot of limitations in systems out there that have to do stuff. So, any other questions? Going once, going twice?
How does this compare to MITRE's sticks, and why would you use this over that?
Okay, so it doesn't actually compare to sticks, it compares to Cybox. So MITRE has a huge alphabet soup of stuff. I work pretty regularly with the people at MITRE. If you think of it in terms of the OSI model, many layers. The artifacts are down here, the indicators are about here. OpenIOC is here. MITRE has an equivalent called Cybox. Sticks is basically their buckets that they put the entire OSI model in. So Sticks is basically something that you would stick an IOC or a snort signature or various other indicators inside of. So Sticks is used for basically passing an entire intelligence dossier. It can include TTPs, include threat actor groups, include campaigns. You're not going to see that in OpenIOC. To me, that's one of the reasons you would use OpenIOC other than Cybox. Full disclosure, we released OpenIOC as open source. A month or two later, MITRE released Cybox 0.1, which was all of our indicator terms in an XML wrapper. Since then, they have greatly expanded upon them. The difference to me is the fact that we have a working model where we have a vendor product that regularly consumes this, and it's basically lean and mean enough for a vendor. They've taken the approach of they're going to enumerate everything that is out there. So Cybox supposedly will describe any event or entity that can exist or happen on any enterprise network. We pretty much are like, here's what we've been using for IR. The happy medium is somewhere in between. We need to expand our number of terms and stuff that we cover over time as we cover more stuff. Theirs is a bit too encyclopedic right now. If you have a product that spoke Cybox, you could probably use it in the same way as OpenIOC. We haven't really done a comparison of the 1.1 features. There are definitely some features in 1.1 that are not in Cybox. There's nothing to keep MITRE from copying those in either. The answer will be realistically what works with your tools. Sticks is a bigger, larger piece. And realistically, a lot of things can interoperate with Sticks. And the answer is there's not any one particular one that is right. I think what you're going to see is you're going to see people using the ones that work with their technologies over the next couple of years, and maybe 5 years from now or 10 years from now, there'll be a clear choice. But realistically, you could use either Cybox or OpenIOC to do most of the same stuff, aside from some of the features that we've introduced in 1.1. Question back there.
You may have answered, I'm not sure. The IOCs that you've listed here in the context you referred to, does that include the source of where the IOC came from and anything related to that, or is that back to the campaign and that kind of stuff?
So that's back to the campaign. So the IOCs have metadata fields. You can put as much or as little information in them as you want to. Realistically, we include metadata in IOCs to give context, but we track them in an external database, and that information is derived from there. So when we write an IOC, we will say this IOC was seen on this engagement, it's associated with these threat groups, it's using this malware family. However, it's much more, I think, appropriate and efficient to track that in a database and then check it with your IOCs. As I said, we do have kind of a document storage problem right now with IOCs, and that's because they are really a communication mechanism, and people have been using them as document storage because people don't have better solutions. So you can enumerate those things in an IOC, but I think it's better to have them in an Intel database because it's better to update stuff in your centralized database of knowledge and then pass it back out to your indicators that are going out in the field than have to go back and change every document you've got every time something gets updated.
And obviously, if you want to share your IOCs, it's nicer not to have that information in the IOCs themselves when you're sharing.
Well, there are a bunch of ways that you can strip info out, and we do that on a regular basis. The parameters piece in 1.1, do you want to talk about that, Will, or should I talk about that? So one of the things that we did in 1.1 is we jiggered the structure of the IOC to be slightly different. It basically has a metadata section, which is a header. That's metadata about the entire IOC. There's then the section which is the logical matching piece that I showed you. And then there's another thing which we call parameters. Parameters are assignable metadata. So basically any of the components in the matching section now have effectively a little notepad that travels along with them. So you can write your own application-specific logic or organization-specific logic and stick it in the parameters. The reason we did that is the matching part, in theory, matters to everyone. However, your organization may have a set of stuff that doesn't matter to anyone else. Mandiant may have a set, somewhere in the US government may have a set. You can stick those in the parameters, and then you can basically do things that trigger when you release it. You have a script that goes through and says, anything marked release to George, send to George. If it doesn't say release to George, don't send it to George. And we've just really started exploring that in this past year. The possibilities are kind of endless, and that's one of the reasons we did it. But the other thing you can do is just programmatically go through and be like, yeah, don't release any host names or IP addresses or any other thing like that. The parameters allow you to be much more fine-grained. So, John? Well, so that's the thing. In the database, we're going to keep track of everything. I'm just saying if you look at solutions that are out there that are doing much more complicated matching than, like, say, an antivirus, and considering all these things and analyzing a lot of the Windows hosts, you do run into technical limitations of time because everyone basically wants stuff to happen right away. They don't want to tie up users and machines. And it's all well and good to say, OK, we take up a little time on one machine when you're checking with an endpoint technology. But when you scale that to tens of thousands of hosts or hundreds of thousands of hosts, the little bit of extra overhead can become unacceptable very quickly. So yeah, in the databases, we have very different rules for what we get rid of and what we don't. And it's not like we necessarily delete IOCs because they're not being used. But if somebody who's using an endpoint technology comes to you and says, I need you to prioritize the 10 most important things I'm seeing right now, you want to do that off of your Intel and say, yeah, don't worry about that thing that hasn't been seen in 5 years. So.
Then again, I think your prioritization should be in your ETL, right? I mean, it should be
in your what?
Your extraction layer. So if you're looking at a data store, I mean, you format the data after it's extracted from the data store. So if you wanted to prioritize data, it would be in the database versus actually the data.
Right, and as we move towards doing as a data-driven model, that will be the case. My goal is to be able to ask a database of, I want to see these threat actors in this industry in these past 6 months, go. However, show me a security alert or bulletin that has that now. Everybody's got a PDF with a list of IP addresses in it. So it makes great theory. We just have to actually get there as an industry. Anyone else? Good. All right, I will now pass the baton and the whatever to Will, who's going to tell you about his IOC writer script.